Good morning, everyone. This is Mrs. Rona, and I'm going to talk you through how to do Intro to SEP6 with energy. We're going to do two scenarios together. This is page 19 of the 2023-2024 packet, so you can follow along and take notes in your packet. Let's go. So we have a scenario. It says two students are testing their Nerf guns. Student A uses a Nerf gun that launches the Nerf dart at a velocity of v, so I'm going to highlight that. Student B uses the same Nerf dart, so that's also important, but a Nerf gun that launches it at a velocity that is 2v. So that's what this picture over here is showing you to the right. One has a velocity of v, the other has a velocity of 2v. And we can see we've labeled a height of 0 meters. So initially they're at no height. So that's going to help us make our LOL. And so the question to answer is, which dart will end at a higher height? And so this is a classic SEP6 question in energy. It's usually comparing two situations. You're going to draw an LOL for dart A, you're going to draw a LOL for dart B, and you're going to use energy concepts to explain which one ends at a higher height. Most of us can probably predict that already. It's actually dart B, right? It's going faster, it's going to go to a higher height. We could explain that using kinematics, but let's try explaining it using energy. So I'm going to draw my LOL diagram. So first, initially, you want to read right above your bar chart where it defines what initially means. Initially is at the ground level after it's already been launched. So ground level, that's a code word for meaning no height. So there's initially no UG. After it's already been launched means it's already moving with some velocity. So I'm going to give it some kinetic energy. Now the reason why I'm not giving it full kinetic energy is because I know I'm going to have to compare this to dart B. Dart B is also launched from ground level immediately after launch, so it has no UG. But if you recall the scenario, dart B was launched with twice the velocity. So it's going to have more kinetic energy. And so I want to set it up so that I can do that. I can make it have much more kinetic energy so that I can compare these two initial scenarios. They both start with kinetic energy, but dart B starts with more kinetic energy. The O, the middle part of our LOL diagram, tells us is where we would put if there's any energy added or removed from the system. In this scenario, it says ignore air resistance. We started after it was already launched. There's nothing pushing on the dart, so there's no energy added or removed. So whatever we started with, we must end with. So let's take a look at the final for dart A. It says at a maximum height. Now there is something implied there that we need to remember from kinematics, from unit 1, that at the maximum height, what's the velocity of the dart? And the answer is 0. So we can write ourselves a little note that this is a velocity of 0. That's a code word meaning that it stops. And so at the maximum height, there is no kinetic energy. So all the energy I had at the beginning that was K has now transformed into UG. And so I'm going to shade this in. Same kind of thing is going to happen for dart B. It's at the maximum height. No velocity there, so no kinetic energy. And so all the kinetic energy turns into UG. So then we can shade that in. All right, so writing your explanation for these is really going to still take that same format that we've done the last unit, where we say, given that, this means. We select some evidence from the prompt, we add some reasoning. So let's take a look at this one that's kind of given for us. And we start with initially, so we start with our initial LOL. So it's given that dart A has, is it more or less the same or 0 mass? If you look up here, we circle or highlighted that it was the same Nerf dart. If it's the same dart, they have the same mass. And dart A has less velocity. That was given in the prompt, the idea of the mass and the velocity. So I show, meaning like I drew my LOL to have less initial kinetic energy. You're describing why you drew what you drew between the two initial points. We also want to talk about the UG. So given that dart A and B have the same mass, and they're both at 0 height, and this is initially, okay? I show dart A and B to have 0 initial UG. So you want to explain both your kinetic and your potential energy for the initial point. One thing that students often miss on this is they forget to talk about mass. So why do I have to talk about mass? Why can't I just talk about height? The answer, and velocity, the answer is down here with our equations. Kinetic energy is 1/2 mass times velocity squared. UG is mass times gravity times height. So both of those depend on mass. And so if you're going to talk about them, you also need to address the mass. Okay, so then this line is given to you to kind of divide your thinking. We talk about the final LOL. So given that at the end, both darts reach their maximum height, that means, and we talked about this, that's code word for meaning they have 0 velocity. So both have 0 velocity. So I show dart A and B to have 0 final kinetic energy. Explain why we didn't draw kinetic energy at the end. So now this last piece is how did you know to draw a different amount of UG? So then I show dart A to have less final UG because, and there's a physics concept we need to bring in here, and the idea is conservation of energy. So because energy is conserved, so I'm going to say since A started with less K, it ends with less UG. So we've established why the UG is less for dart A. So then since dart A ends with less UG, we restate that in our end bottom statement, and has the same mass, this means dart A ended lower. So thinking back to Unit 2 where we had to talk about net force causing acceleration, in Unit 3 you have to talk about conservation of energy at the end of your explanation to tell me why something has more or less energy. All right, let's go on to the next one. So scenario 2 says 2 matchbox cars with identical mass, let's highlight that, are launched from the bottom of the ramp with different velocities. A is launched with twice the velocity of matchbox car B. Ignore friction and air resistance. So they're both going to be launched and they're going to go up. It says, which car will reach a higher height on the ramp? That's what we're asking. So here's a little cheat sheet just to kind of help us compare initial values for the cars. A has twice the velocity, so a greater velocity than B. They both have the same height initially, right? They both start on the ground and they have equal masses. So we're going to use that to draw our LOL. So initial is when it is moving, so that means their kinetic energy at the bottom of the ramp, means there's no UG. So since A was moving faster, I'm going to give A more kinetic energy than B initially. They both start with 0 UG because there's no height. Since there's no friction or air resistance or any rockets or anything pushing on the car, all the energy is going to stay in the system. So I leave my O by itself, and then at the end, at the maximum height, this is very similar to the last problem, that's code word for the final velocity is 0. So there's no kinetic energy at the end, and so all this energy turns into UG. There's no kinetic at the end, all this energy turns into UG. So they have different amounts because they started with different amounts of energy. All right, so what I want you to do now is pause this video and try maybe just this first row. Given information about mass and initial velocity, that means info about kinetic energy. And then I'm going to go through it. Okay, hopefully you tried that. So the info about mass is they have the same mass. Oops. But A has more initial velocity. This means mass and velocity, we're talking about kinetic energy. So this means A has more kinetic energy. All right, pause the video and try the second row now. All right, so let's talk about mass and initial height. Same mass. And at bottom of ramp, right, that's what was given. This, I'm going to say both. I should say both have same mass and start at the bottom of the ramp. This means both start with 0 UG. UG is based on the mass and the height. All right, Pause the video and write something about the final location. So what we know about the final location is the max height. So given that both cars are at the maximum height at the end, this means they stop and have 0 kinetic energy. The other thing kind of implied there is if they have 0 kinetic energy, so all remaining energy is UG. So then you want to compare the final energy amounts. So A ends with more UG because, oh sorry, the because is right here, because energy is conserved. So since A started with more K, oops, sorry friends, this is gonna die. It ends with more UG. Sorry about that, everyone. So then you have this concluding statement at the bottom. Since A ends with more kinetic energy and has the same mass, oh, I'm so sorry, that threw me off. Same UG is what we were talking about. More UG. Let's start this over. Final statement. Since car A ends with more potential energy and has the same mass, then matchbox car A will go higher. It's important to talk about mass because if they had different masses, this might not necessarily be true. So we want to make sure we include mass there. All right, thank you for watching.